Question 5i, ignore that stuff. That's from the question above it. Question 5i, a function is graphed below. And there it is, kind of just like a piece of spaghetti, up, down, up. A possible equation for this function is, okay, now one way you could do this, anytime they want you to match something, it's calculator town. So you can type all four of these into y equals choice 1, choice 2, choice 3, choice 4. Type them into y equals exactly as they're presented. Click graph. Whichever graph matches this graph, the picture, you found them. Now, I'm going to show you the more algebraic way on how to find this, and it's actually as easy, if not easier, than the graph way. So we're going to use something called the root factor theorem. Now, what that means is you got to find the roots. The roots on a graph are where my function does what? The roots, the zeros, the solutions are where my function does what? Crosses the x-axis, so it crosses them here and crosses them here. That's not, I mean, I'll leave it like that. It's kind of bloated, but I'll take it. So this root over here is x equals what? Where does he cross the x-axis here? -3. And where does he cross the x-axis over here? Well, meet, I should say, not cross, but x equals 2, right? Facts. Crosses at x equals -3, crosses at x equals 2. What the root factor theorem says, if x equals -3 is a root, that means x plus 3 is a factor. You literally flip the sign and you put an x in front of it. That's it. Parentheses. The reason I knew I had to use this is because I really quickly looked at my 4 presentations of these equations. They're all in factored form. So I said, oh, if I could just turn this guy into factored form, I can really quickly match him. And that's exactly what we're doing. So that means if x equals +2 is a root, what's my factor? It's a +2, that means it's going to be a -2. Now you can see the +3s and -2s kind of scattered about, so we have to lock it in here. What's interesting, what's different about the root in my graph over here versus how the root happens in my graph over here? What's the graph doing at -3 versus what is it doing at 2? At -3, it passes right through, and at 2, it does this reboundy, bouncy thingy, right? It kind of hits it and shoots right back off. So what happens is that's called a double root when it does that rebound. If it passes right through, it's a single root. If it bounces off of it, it's a double root. So really, we have 2 roots at +2. So we have 2 factors of x minus 2, x minus 2. Okay? Now remember, blob times blob, we don't write x minus 2 times x minus 2. We would rewrite this nice cleanly as x minus 2 squared. In other words, it bounces off of it twice, x minus 2 squared. Okay? Now you multiply factors together. So I'm looking for which of these 4 choices has x plus 3 and x minus 2 squared. That would be choice number 3 right here. Okay, because we have x minus 2 quantity squared, x plus 3, and the other ones have, you know, some good wrong answers, but they're tempting. So the answer here is going to be choice 3, root factor theorem.